Hey guys, welcome to this video. In this video, we'll be talking about what is HTTP. Okay, one second. Okay, fine. So we're going to talk about what is HTTP. Well, this, as to mention, I already told about we will be following a particular basic backend guide, and I would like to clear the first internet questions that are related to the internet itself. So that's why I'll be talking about. First of all, what is HTTP, and then there are kind of types of HTTP, like versions of HTTP. Before there was HTTP version like I think 0.98. We'll just talk about all of them. So basically, HTTP is like kind of like a internet way by which you connect to somewhere online server. You just like your web browser ask for some information to be loaded on the website. So basically, go on a website. You want that website's HTML files and the CSS files and the JavaScript files. Well, obviously you do have the knowledge about the CSS, HTML, and JavaScript files. As long as though you will not ask for these files from the server, you will not get to see the website. Okay. So what happens? It makes an HTTP request to the server, and the HTTP request can have different type of. It has it has a header. Okay, let me just show you what it has. So okay, I'm gonna do something like insert a. Okay, this is kind of yeah. Okay, so okay. So I'm gonna do something like here. So HTTP contains, first of all, it contains the HTTP version, like which version of HTTP the server is using. Well, there are quite a lot of versions of HTTP as till now. I will talk about all the versions, but just keep in mind, just keep that thing aside for now, because we'll be talking about what does this HTTP request contains initially. Okay, as by default, what request are we making to the server? So first of all, is the HTTP version. So basically, whatever version of the HTTP they're using, the server is using, it's not. It doesn't depends upon which version you're asking for. It only depends upon which version they are using, the server itself, the website developer. And then there goes like the URL of the request, and then we have the URL of the request, like where we are making the request to. The URL can be literally anything. Maybe like we're going to google.com. The URL will be google.com, and then it will send us back all the HTML files and stuff as that. And then we have the HTTP method. So there can be quite a lot of methods of HTTP. The most common two is just like the post request and the get request. Basically, we make a get request in order to get something from the server. We want HTML files, we want JavaScript files, we want CSS files. We'll make a get HTTP method request. That means basically we want something from the server, and we make a post request to the server if we are going to upload something to the server. If we are giving something to the server, like we are submitting a register form. It basically means we are sending some data to the server, not the server is giving some data back to us. Okay. And then we also have the HTTP request headers. So basically, these request headers contains a lot of things. It does contain the content type, what content we are sending to the server, whether it be the text, it be in the text format, in JSON format, in image format, in array, in literally any format you want it to send the data. And it contains quite a few more things. It contains the cookies, it contains the content length, it contains like whatever data you are sending to the server. It will be added in here in the request header, whether it be the tokens, whether it be something else. We'll talk about brief in afterwards. And then we have the HTTP body, and this HTTP body, if the method is post, then we have the HTTP body. So basically, if the method is post, that means we're sending some data to the server. Then we will also give it a HTTP body, which means we'll give some body for the in the request. The body will contain, let's suppose, our email and password that we are sending to the server, and then we'll get back some response back from there from the server itself. Okay. So these are the few things that we have in here. And now let's talk about the HTTP method itself. What is HTTP method? And I already mentioned about the HTTP method. So get is used to get some specific files from the server, like the HTML, CSS file, or JavaScript file. And post method is used if you want to submit some information to the site. Maybe submit a email and the password. And then we have the HTTP request headers. Okay, 1 second. Okay, yeah, I got the image here. So this is the HTTP. You can just put this thing right here. It this okay. I also had the arrow stuff. Where is the arrow? I'm not sure if I'm using the right thing or not. Draw. Oh, draw. Yeah, we have the draw option. So this is the HTTP request headers. This is exactly what it looks like. We have a path. Path just basically means where are we going to make a request to. Basically, this authority is like our base URL of the website that we are currently on. Let's suppose I'm in the google.com. So the authority will be by default www.google.com. And the method is like whatever HTTP method we are applying on it. So by default, if we are going to get some files from the server, HTML file, JavaScript file, JSON file, CSS file, or any other file, it will be a method get. And the scheme is HTTPS, which means this website has a SSL certificate installed, which means this website is secure. And the accept is text/html. So what does this accept means? So basically it means when we make a request to this URL, we make the request to www.google.com/nothing, just path is like slash. So what it means, we are only accepting the text/html type data back. So if they try to give us back data like in the JSON format, we will actually accept it because JSON is also in the text format. So let's suppose if they try to give us data back, like maybe they try to give us back an image, we will not be able to read the image because we are saying we only accept a file in type of whether it be a text file, whether it be an HTML type file. So basically it's just like text/html means you're able to receive a HTML or text file. And you can also receive the JavaScript, the CSS with this format. Okay, just keep that in mind when you say text/html, which means you can receive any file which is in text format. And then we have the accept encoding. Basically you're saying I accept this kind of encoding. So gzip is like compressed encoding. So basically quite a few servers do what they will compress your request, compress the response, that they will send you back some HTML file. They will send you back some HTML. Okay, look what happens. So when you want to make the request is a little bit more smaller, what usually we do is we use the compression node module, and that does what? That applies this gzip encoding. So basically, when you're sending some files back, let's suppose I'm sending HTML file from the server to the user, the HTML file will be converted in some small binary, some small codes like maybe something like this. My HTML, and then the hello, and then this, like basically my HTML tag will be converted to something like this. It just does what? It just decreases the space, it decreases the size of our HTML file or of a CSS file or for JavaScript file, of literally of any of a file, whether it be the image or anything. It just decreases size by tremendous power, by a tremendous type. So when the browser receives this text file, it knows basically the browser will not be able to read it. So it's already saying I accept this encoding, and by default the browser can uh, convert this gzip a file back to a normal text file. So if I apply compression on an HTML file, it will be converted back to a normal HTML file in the browser itself. And this is very good for decreasing the response time for the files being sent from the server to the client section. And we also have the deflate and VR. They're pretty much the same thing. And then we have the accept language. It's not important, but we're saying okay, by default we accept the United States English language. So we also accept the English language, which whether it be any country. And we have upgrade in secure requests, let it be there. And then we have the raise user agent. So basically user agent is like you're sending your software information to the server. It's not only Mozilla 5, it has a lot of more things. So there can be like Mozilla 5, Safari, and the Chrome in one user agent request. So basically they're specifying which version of the software you're using. They're not specifically specifying your browser version, but they're saying in general they're assuming which browser you might be using. And they also get to know, with the help of this user agent, they get to know which operating system you're using. Yeah, that's true. and probably they can also kind of know like are you using Windows or are you using mobile phone. So with the help of this user agent, they can get to know these kind of informations. So then we have this body method, we have this HTTP body. So basically just the same thing. All we do, we send some body in the JSON format. So body is just like our, let's suppose, our email and our email value. Our, it's just like object format. We have the email, we have the email value, and then okay. So there's a thing. When you send a body from our HTTP request, maybe to the server, you cannot directly send it in the object format. You need to convert it to a string format before sending it to the server, because you cannot the HTTP body cannot contain a direct object. It will be only able to I think one second. Uh, yeah, we need to convert our object into a string first of all before sending it to the server. I will be talking about briefly in this thing, but understand it. You need to convert your object into string or your array into string before sending it to the server in the body. So then we have the HTTP response. This was about the requests and the HTTP methods we already talked about. I will just still mention it here. Let's go to draw. Let's go here, the straight line. So we have a couple of HTTP methods, to be honest. I'm just going to mention the post and the get for now. We have a few more options, but I will just talk about them when we talk about the versions of the HTML, versions of the HTTP request. Yeah, that will be better. And this is not working. Fine. Okay, we have the post and get request, and then we have the URL, and then we have the HTTP version. I will also talk about the HTTP version afterwards. So, how long has the video been? 12 minutes is fine. Well, this was the HTTP request. Now we need to talk about the HTTP response that we send from the server itself. So this request is this HTTP request is the thing that we are sending from the client to the server, from the browser to the server. And HTTP response is something that we're sending from the server to the client. Okay, so this is HTTP request section. And let's say HTTP response, it contains a couple of things. First of all, HTTP response contains a status code. Basically, status code helps the browser to understand what happened to the request. If you go to the network tab of your browser, you will notice like there are like status codes like 200, 200. If something failed, it shows like 400. If the page was not there, it shows like 404. If there was some issues with the server, it shows the status code 500. If you got redirected to any other page, it shows the status code 301. But it all depends upon the cases. So you need to have a good understanding about HTTP status codes, because you will be sending the status code with your HTTP responses. So first we have a status code in an HTTP response that we're sending back to the user in order to notify the browser like what happened to the request. Did we allow the did the request, was the request completed successfully? Was something wrong? Was the user already logged in or something like that, stuff as that? And we have the response header. Just like we have the request header, we also have the response header, which just contains things related to the response itself. I will also mention deeply what the things this HTTP response contains. We'll talk about that afterwards. And we have again the optional HTTP body if you want to send it or not. Well, in the response, it doesn't matter. Okay, if the user is sending a GET request or a POST request, you can send HTTP body anyway. You can send a body back to the user, like in a response. Okay, this is the data. This is the response that we got from the server. It goes like it just honestly optionally. It's kind of like you can even send any response back to the server, or you cannot even send the response body to the server. So it's just like 20%. Okay. So basically, if you only want to send back the status code, like how the request was done or not, you can only send the status code. But if you want to send some HTML, some body back to the server, back to the client, maybe you want to send okay, you want to send say something like, okay, this is your data, this is the credentials. So we have a optional HTTP body option there also, so you can send the HTTP body as an optional tag. Okay, we have issues right here. Okay, fine. So we have a couple of status codes option. So first of all, if I mention like them, I'm gonna go like this, go like this, and we'll just like this. So it goes like this. Okay. So we have 5 types of HTTP status codes. If the HTTP status code contains 1, XX means it can be literally 101, 102, 105, anything. But if it's starting from 1, that means uh, okay, the request is being processed. So basically, if we get like 100 status code back, or 105 or 100 something like that, it basically all says, okay, the request, your request is being processed. Please hold on till your request is completely processed, but you should wait unless until your request is not completely processed. So it's like, you're keeping making requests to the server, and you just keep saying, okay, wait, it's processing. And then we have the request type of 2xx. In here, basically the 2xx request means if you get response 200 status code, that means your request was successful. If you get a response back like 201, which means your maybe you're making a blog post, it means, yeah, your blog was successfully created. So it just says success in by default, and we have like 201 means created, 200 means normal success. Okay, so if you see response starting with 2, that means basically whatever you were doing, it was successfully done. If you see response a status code starting from 3, whether it be 300, 302, 301, it means you were redirected from one page to another page. Mostly it's like 301. So if it's 3x's, which means any code starting from 3, means you were redirected. So when can you see, when are you, when can you see this status code 300 or 301 or anything starting from 300? You can see this on when, let's suppose, if you're on a website, you're trying to access some feature that the website doesn't give anymore, and they have another website that they provide the feature on, and whenever you click on that feature, you'll be redirected to the website that provides the feature, and they will show you back in this 300 response code, which basically means you were redirected when you clicked on this thing. This HTTP request made you redirect from one page to another one. It's just like informing the browser what exactly happened. If you're sending back success, the browser will be not be very much aware about what happened. You're sending back success, and you were redirected to another page. But you need to send back specific responses, so it will be better for the browser to understand it, and better for the user experience also. And then we have the status code starting from 400. So 4x just basically means error, something went wrong, but on the client side, not on the server side. So maybe you were trying to log in and your password is incorrect. That means you got a 400 error. You're not allowed to go in there. So we have a couple of 400 errors. So it just means client side error, and I will mention what we have. The 400 means normal error. The 401 means un what's the spelling? Un no. 1 second, let me just check on the Google. Unauto oh yes, it's AUTHO. My bad. Means unauthorized. Basically, you can send back this 401 status code in case the user is trying to access some page that is not allowed for that user to see. You can send back this 401 response status code back, and basically it's just going to tell the user, all right, you're not allowed to use, see this page. You're not authorized to see this page. And then we have the 404 error. It means doesn't exist. So mostly you might have seen the page, the no page means like they're showing like 404 no page found. It's just like 404 means it was not found. It's not only about the page was not found. Maybe whichever URL you're trying to make a request on, it will return back 404, which means this URL was not found. It's not by default behavior. You need to set up all these things, all these status codes, because they're not by default applied to the by the browser itself. All of these, the default status code is like only status code 200. Whether even if you're sending a failed request back, it will be the status code 200 unless until you're not specifically mentioning some other status codes. And at the very end, we have the status code starting from 500 like 5xx. If you see any status code starting from 500, which means that basically means something went wrong on the server side, not on the client side. Now I will say it as server side error, and there's no particular mentions here. So whenever you see something like when you try to go to page, it just shows like status code 500 and something, just keep in mind it means like there's something went wrong on the server side. Maybe they're under maintenance mode, maybe something went wrong, maybe they're updating something, maybe something crashed. Just understand this basic thing. It means something went wrong on the server side, nothing else. So we have then the HTTP response thing. This was the status code. So maybe I will make it a little bit more smaller distance. I guess the distance is very big between that. Okay, let me make another arrow here. I will just go like here. Then we have the response header. Well, I will not. This response header is not fully perfect. It just doesn't show quite a few things, but still, whatever it shows, I'm gonna show it here. Okay. So by default, we get sent back this response header. This response header contains a content encoding type, which by default is BR, which means a normal thing. So you can send, you can, if you're using some compression modules on in Node.js, okay. So it's just going to send back encoding type as gzip, which by default you can see here we are accepting the coding of BR, gzip, and deflate. So by default the content encoding is like BR type, so it should be all fine. And then we have the cache control, which is by default set to private and max it 0. I will not be talking about the cache control here. We'll talk about it afterwards if we need to. Cache control is like basically you're catching some of the contents, which means you're saving some of the CSS file and stuff as that in the browser itself. So it just the next time the things get loaded a little bit more faster. Or not only in the browser, it's not only about browser. You can all you can actually catch on the browser itself, but on the nearer server, whichever server is just sending back the same data to the client, it can catch the files, so it doesn't have to make a request to your server, and it can directly give it the files. It's a little bit complicated. I will make it clear afterwards. Then we have the content type. By default the content type will be set to text/html, or in Node.js when you try to send back some response to the server, when you use the Express server, it's very clever. It automatically sets up the content type according to whatever you're sending to the server. You're sending to the client section, which means if you're sending some CSS file, some HTML file, some JavaScript file, it will be the content type will be text/html, and the character set will be set to UTF-8. So character set is like it just describes what is the encode, what is the how was this text written in. So UTF-8 is specifically stands for the HTML files. So it's just like a character set for the HTML files. Just keep that in mind. I get it. It's not so simple. Then we have the date. Date just specifies like when was this response sent to the server, sent to the client. Then we have the status. Like I told you, by default the status is going to be 200. Even though you receive some HTML files, the CSS files, the status code is by default going to be just 200. We just says, okay, you are able to get these what is it? It just says, okay, the thing was successful. If something went wrong, the status code is going to become 400. Then we have the strict transport security. Let's keep that thing aside as of now. We have the extreme options. So I'm assuming that extreme means like we have the iframe in HTML. It will only let we to us to use the iframes in the current same origin in the current on the current URL. We have a couple of more response header options, which it goes like, you have a set cookie option also. You have a couple of more options. So set cookie, when you send a set cookie header in here, it basically allows us to set some cookie. And what does set cookie means? Allows us to set a cookie means, well, basically if you want to save some cookie in this user section, you can do that in here. I get it. You don't know about the cookies. It's okay. So then we have the response. We have the HTTP body itself, and you already know about it. Like HTTP body, you can set it normally. It doesn't have to be something else. You can send it with the HTTP response itself. So it doesn't have to be anything. You can only send the status code, or you can send the status code and also the HTTP body. So it all just sums up together. It doesn't have to be anything more complicated. Okay, so let me see. We have a couple of more options. Okay, so these things are actually related to HTTP version 1 point. I think it's 1 point what? I think it's 1 point. I think it's 1.0. Like 1 point. No, it's actually 1.1 version of HTTP. So yeah, we have a couple of HTTP versions. Okay. So I'll just talk about the HTTP versions now. As I told you before, we will be talking about the HTTP versions, and I think now is the time to do it. So let's do it. How do I increase the... Okay, I need to add a new page in order to do something new. So let's add another page here. Can I rename this new section to HTTP requests? Now we'll be talking about the HTTP versions. We have a couple of HTTP versions, which goes like and we have HTTP 0/0.9. This was a very earlier. This was the very first HTTP request that was created in 1909. It's also known as the one-liner. So this was a very basic request. You in this HTTP version 0.9, you are not sending any header like we told about. Like we have a headers here, like we have the request. In the request we send headers, we send the body. But in this HTTP version, in HTTP version 0.9, you were not able to send any bodies. So let me also mention these things. Not able to send body. Only get method was allowed. So you're not able to make any post requests to the server. You were only able to make get request, and uh, only HTML content type was allowed. So back then there was literally not really any CSS. Only HTML was created. So the HTTP version 0.9 was only made like this. Not able to send bodies, of course, because so no headers. So we were not having any headers in the response or in the request itself. The only method that we were able to use was the get method, and the only thing we were able to receive from the server was just the HTML type files. Literally, we were not able to get anything else other than that. And it was created back in like 1991, and afterwards we get a little bit more better at doing things. Let's copy paste here. And then came the HTTP version 1.0, which was a way better than we had before. It came in 1996, and this HTTP version 1 increased a lot of more things. Okay, it was a much better option. So now what we had for this HTTP version 1 was is basically we were able to send a lot of things in the request itself. Now in here we were able to send the request. I mean, we were able to send the headers. In the request headers, the request headers looks like this. Request headers contain the host, which means basically the base URL of the website. A user agent. User agent is like the browser that the user is using or the software. And we have the accept method. Accept method. So that's it. These were the request headers that we were allowed to use in HTTP version 1.0. Basically, you're getting to specify what you will be accepting from the server. Either you can accept every single thing by saying star, or you were able to accept something particular, whatever you want to accept. And the user agent just specify like which software the user is using, and the host just specified which URL is making on which URL, which is the base URL of the website that is making the request. And the response header was like this. Response headers look like this. We have the content type, we have the content length. So content length just specifies like our content length, which means if we are receiving the HTML file, it specifies the HTML file size in bytes. And we have the expires option. Expires doesn't really much consider anything, but just like it was something that we were seeing that time. And we have the last modified option, which is specified like when we actually modify this HTML body, this the text that we are sending back to the server. And we also have this server information, which goes like on which server the code is hosted on. It can be either Nginx or Apache. So the response header also used to send this server information, which as of now is really dangerous to send back. You should not send back. It actually does not only send this thing; it also sends like which version of the things you're using. For example, it sends back we're using Apache 0.84 version, and this is very bad for the hackers, because hackers can actually exploit. They will know, okay, yeah, this server has a bug, so I can exploit this server by this information. So server is like where the code is hosted on. And then we also have the response body, and boom, that's it. We can send the response body. We were able to send the response body in a what do we say, in this method, in this kind of type. Okay. And there was kind of like handshake pattern in this option. So yeah, we were able to send some kind of handshake patterns. I get it. Let me see what was the handshake pattern. So get request was allowed. What were we able to make at the post request in the this one? Let me think about it. And yeah, we were able to send the status codes. Status code. Wait. Let me think about this one. Let me think about it. Yeah, they added status code option. So basically in here we were not able to set any headers. Basically we were not able to send any status code in the response itself. And in the HTTP version 1.0, we had the HTTP methods like post, get, and head were added. So these were the options we were added in here. I'm not pretty much sure about the head option, but I'm sure about the post and get, and you're also sure about it already. So this was what we were able to do in HTTP 1.0 version, but there was kind of three-way handshake kind of system going on in there. So basically, let's suppose you were making a request to the server. You were only able to make one request to the server at a single time. Okay, you made a request to the server will get your request, and then the server will send back the response, and then you will see the response, and then only then you will be able to make another request. So you cannot make multiple requests at a time in this HTTP version 1.0, and this was kind of the limit of having this of using the HTTP version 1.0. And what is the three-way handshake? Basically, the three-way handshake is like you are choosing some. Let's say you're choosing number one. You send the number one to the server, and the server said, "Okay, what I'm going to do." Okay, you send this thing to the server, and the server then basically added one to the number that you send it, and it is going to send this response back to you. And after you receive the response back, you will see what happened at the very end. Okay, so basically this is like the thing. You send the response, you send some data to the server, the data server will send you back some response, and then you will again send some data back to the server. Just like, unless until one request is not has not been completed or closed, you will not be able to make another request. So you're kind of limited in the version HTTP version 1.0. And then came the HTTP version 1.1, which we are currently using. I know there are a few more versions of HTTP, but the mainly like everyone is using is HTTP version 1.1, which was like built like after like probably 3 years of HTTP version 1.0. It was made in 1999, and basically this thing HTTP version 1.1 is whatever we learned back in what is HTTP. It's just like our current thing. It has a lot more options. Okay, literally a lot of more options. You can send chunks. So you can set up caching. You can send the character set. You can send the language. You can set the cookies. You can set the a lot of new status codes were there. You can it also by default accept the gzip, the deflate, and the br encoding types, and it has quite a lot of things, like literally every single thing we talked about, whatever we talked about in what is HTTP. And then came the HTTP version 2 and the HTTP version 3. Well, the both of the things are a bit complicated, I get it, but we do need to understand it. So basically, this HTTP version 1.1 also has kind of limits. I will not call it a limit, but yeah, there's something. So, huh? Acha. So basically, when you go on a website, usually the website will contain a JavaScript file, a CSS file, a lot of images, and an HTML file. So what we do in the HTTP version 1.1, it's a default one. You make a request for all of these things. You make a request for the HTML file, you make the request for the CSS file, for the JavaScript file, but you make all these requests separately. You don't make them together. So this thing was fixed in the HTTP version 2. It's not like this thing was fixed. It's just basically like this thing was made better, because literally I think a lot of, like, most of the developers are still using the, not actually still, most of the developer are using the HTTP version 1.1, because the issue with HTTP version 2 and 3 is like most of the browsers still don't support the HTTP version 2 and 3. That's why most of the people do not prefer to use HTTP version 2 and the HTTP version 3. So the what was fixed in HTTP version 2 is basically you were only making one request to the server, and the server was giving you back all of the files only in one request. Like they were compiled all together, and the browser will decompile it, and boom, you're only good to go with only making one request to the server. It decreased the server bandwidth. That means the server doesn't have to receive a lot of requests. Only for the user to come on a website, he has to at least make like 5 or 10 requests to the server. Now all you need is make one request, and that one request is going to get back a response, and that response is going to give all the information to the user to be like, okay, here we go, enjoy this one. And we also were having some the Huffman header compression. So in the HTTP version 2, our headers are also compressed, which means the requests are received a little more faster. Okay, before we have the encoding types, which means we can encode our body of our, like, whatever we're sending to the server, we're sending to the client. But now in HTTP version 1.2, HTTP version 2, we're also able to compress our headers also. So let me think, what else did we had in that. Not really much of a stuff, but these were some of the basic stuffs that we had in X in there. I know it's a little bit complicated, but stay with me. Let's see what happens. What is going on here? So this is our HTTP version, version 1.1, and this is the HTTP version 2. So the HTTP version 1.1 basically contains our type that we our HTTP type, the URL, and the version, and the host name, the content type, the content length, and then the content our request body. But in HTML in HTTP version 2, we have we have the pointers. So we have like header frame. The header frame contains this header, and the data frame contains data. It's not like they're not directly showing this data. They're compressing this data in a different compression way. We have an application layer, and then we have the session, which is the TLS, which is just basically our encrypted request, which is basically like we have a certificate on the website. So I don't know if it's related in it or anything like that, but it is whatever it is. So we have like a header frame and a data frame, and then we have the TCP, which is transport request. So guys, listen one thing. I will be talking about all of these networkings in very depth, to be honest, literally. Very soon, once we complete this back in basic section, guys, I want you to be very much professional in this networking stuff. It's very much useful for you. Then we have the TCP and the network IP. I get it. As HTTP2 version is kind of complex. I know. It was not meant to be so simple so that you may never see anyone using it. Like maybe someone wants to use this HTTP version 2, and there's also the HTTP version 3. So basically, the HTTP version 2 offers a kind of a lot of performance boost. It just increases the performance by a dramatic, not actually dramatic, but it does increase the performance by a lot of power. But setting up this HTTP version 2 client in the server, it's a little bit more complicated than normally setting up normal servers. So you need to understand these things. It's a little bit complicated. And the HTTP version 2, there's a thing. Normally, the HTTP version 1.1 will send some response back to the server, to the client, which will be human readable. But when you send a HTTP version 2 response back to the client, it will not be human readable. It will be in a compressed way, okay? Because the header is also compressed in the Huffman compression, and the body is also compressed, so it will not be human readable, and that's something you need to understand here. And I know I didn't specify much about the HTTP version 2, but I don't think you really need to know about the HTTP version 2 as of now. Just understand something like it compresses all the headers in the body, and you just have like header frame and a data frame, other than directly having all the headers and data like that, like openly like that. It doesn't. It's not really much human readable format, so yeah, it's kind of compressed. So then We are going to talk about the HTTP version 3, and do we need anything else after this HTTP version 3? No, I think it's the end of the HTTP request section. So in the next video, we'll talk about how the browser work, and that's not actually complicated. That's actually simpler than these HTTP version stuff. To be honest, this is hell of complicated. Okay. All right, that's nice. Okay, guys. So I've been talking about these things like I said, whatever it is, blah blah stuff as that. But now I paused the video for a couple of moments. I watched like 3-4 videos. Now just feel me, bro. I'm already a professional in this stuff, and I will explain it like crazy. Okay, let's get started with this thing. So we were talking about the HTTP version 1.1. We said whatever we talked about in HTTP is just basically this. But there is a couple of more things that I didn't mention before. So the thing is, like, when you make a request, HTTP request anywhere, it creates a TCP connection with the server. Okay. The new HTTP version 1.1 it creates. Okay, one second. Okay, so basically all of the requests create a TCP connection with the server. Okay. Don't ask me what is TCP for now. It just keep in mind TCP is used to create a connection between the client and the server. We will talk about TCP and UDP briefly in future videos, I promise you, because I'm already reading about the TCP and UDP networking full in depth, so I will give you full in depth information about those things. Okay. So basically, in HTTP version 1, what happened before is like you were able to create one TCP connection, and whenever any response came back from the server, you were able to create another TCP connection. But in HTTP version 1.1, you're able to, basically you're also able to create, multiple HTTP requests connection to the server. But what happened, like the server will only read one TCP connection per, every single time. Okay, that was the limit of HTTP 1.0, and HTTP 1.1 resolved this limit at a point. It and now in HTTP 1.1, which most of the people use, like in by default, it supports up to 6 concurrent TCP connections, which means you can make thousands of HTTP requests, but 6 requests will be completed kind of like together. So when 6 TCP connections will be completed, let's say we make 1,000 TCP connections to the server, to the 1,000 HTTP requests to the server. The first 6 HTTP requests will be resolved like one by one by one by one, or all of them can be resolved at a time. It doesn't matter. But I'm just saying, you can all at a particular moment, you can only your browser can only work with 6 active TCP connections. So, 6 most active TCP connections are allowed. So it means you can make 1,000 HTTP requests, but at the most point, only 6 TCP connections will be resolved, at a time, like 6 or maybe like 6 5 blah blah stuff like that. But at the most point, it can be only 6 TCP connections will be resolved at a time. And there is another thing about the HTTP 1.1, and that is it has a So the difference between this HTTP 1.1 and HTTP 1.0 is this HTTP 1.0 didn't have any, keep alive TCP connections. So basically, when you made one TCP connection to the server, if you made another TCP connection to the server, the first TCP connection will just fail, okay, right away. It will not just allow you to make another TCP connection. But our new HTTP 1.1 version lets us to make at most 6 concurrent TCP connections. And because it how does it allow this thing? Because it added new keep alive connection property. So now in our headers we have a new connection type, which having the and also known as a keep alive. So basically, you can make multiple TCP connections, like at most a 6 one, and the TCP connection that we made before, like the first or second one, third one, will not die because they have the keep alive connection property, which means they will stay there. They will not die. The request will not fail unless until it will not get some response back from the server, or they have a timeout limit. Okay, all of the browsers have a timeout limit. I think probably like 30 or 60 seconds. So if no response was given back from the server in that time frame, the request would eventually fail. It will not just stay. It will not just keep alive forever. Okay, this keep alive property also has a time limit. Okay, it will not keep alive forever. It will fail eventually if there was no response given back from the server, or if it took a very long time for the server to respond to a particular thing. So you need to keep in mind all of these particular things. Like you cannot make a request wait for a very long time. It will not stay alive for that much long period of time, or maybe it may stay alive. I'm not pretty much sure about that. So 1 second, let's Google search it really quick. Max keep alive request time. Okay, the maximum value for this parameter is 5 minutes. Okay, it's 5 minutes. All right, that's fine. How does the keep alive lost? 10 seconds. TCP connection. Okay, one guy is saying like it's around like okay, let's assume it's around like 5 minutes, which is the latest one. Okay, in the HTTP request, the TCP connection will stay alive for at least 5 minutes. If no response was given from the server, it can wait at least for 5 minutes. So we're assuming the TCP connections can wait for at least 5 minutes. Well, what was better in HTTP 1.2 that was bad in HTTP 1.1? I'm not saying HTTP version 2 is perfect, because HTTP 3 is perfect thing, and HTTP 2 is I wouldn't really much prefer you to use HTTP 2. I would say HTTP 3 is a better way to go. And you may ask for the reason why. We'll definitely talk about the reason why. So this was for the HTTP 2 thing. Let me just put it a little bit down, because I will just show you some. I will just make some graphs right here, if I can. What can we draw? Good, we have a paint stuff going on there, right? So let's make a graph. Let's make a system stuff going on for the HTTP 1. This is the HTTP 1.1, and we know it's HTTP 1.1. So let's see how it handles the things particularly. So basically, the HTTP 1.1 is something like this. Okay, I wanted to show something. So let's suppose I make a. I'll draw something. Okay, let me mind. I make a get request get index.html. I make a request for get style.css. I make a get request for let's say script.javascript, and I would like to draw something like this. Not like this. I would like to draw something like a straight line though, not a curved line. Not a curved line. So we're assuming we're making a request like this. I'll probably just copy paste it right there, like that. Okay, I'm not going to copy paste the whole thing. Okay, never mind. It's taking the whole stuff there. Okay, let me just show you this thing. So all of these are like active TCP connections with the server that we're making. We're asking for three things. We are making a connection to get our index.html file. We asking making get request to get our style.css file. We're making get request to get our script.javascript file. And your browser make these three active TCP connections which have the keep alive connection property. So the connection will not close itself if you make multiple connections. At most you can have 6 concurrent TCP connections with the server. So basically what happens like in a HTTP 1.1 version thing is you, like, let's say to get something like to get index.html, we need to make an index.html get request. To get style.css, we need to make a style.css get request. So we need to make we need to make different HTTP, we need to make different TCP connection, we need to create different TCP connections or different HTTP requests to the server to get anything we want. Literally, we want only style.css. We will ask for we will create a TCP connection to the server for asking for this style.css. We want style1.css. We'll create another TCP connection with the server to get this style1.css. So you can see it's very server heavy tasks. For getting anything, you're making a connection to the server. You're asking for the server. So probably let's suppose a normal website might have 10 or 20 files going on. So a user comes on my site, he already is making like 20 TCP connections. They're not actually, like, at most you can have 6 TCP connections. But I'm saying the user is making 10 HTTP requests, 10 different HTTP requests, and you cannot believe how much that's bad for your bandwidth. And at most like 6 TCP connection will be resolved, 6666 like that, and it will also take time for the user to load all these stuffs, because if he makes 20 HTTP requests, at most only 6 requests will be resolved, and then it will go like 6666. So you're getting the point. It does take the time, and all of this get index.html requests will be sent to the server, and the server is going to do its own thing. Okay, it's like, okay, I got the thing in the server, and there is no compression. Yeah, there is compression. When you get the response back, you can get the body compressed with the help of gzip compression. In the encoding, you can have encoding type as gzip, which means you're basically compressing your response body, but you cannot compress your response headers. What does the header contains? Basically, the header contains like the cookie. The thing is that, and that's also something I need to mention here. Okay, so we're just assuming all these are sent to the server. So another very bad thing about this thing, like we're making three. We're asking for the three files from the server, and the thing is, if we have a very long cookie, I'm assuming our cookie, we have a lot of stuff. We have cookies, we have user agent, you have stuff like that. So on every single request, you need to send all of these headers again and again, again and again. Whether it doesn't matter, all of them are same. You still have to make when you make a new HTTP request, you need to send all of these headers again and again in a HTTP 1.1 version. And this is really not a good thing. Okay, if you think about it, you're sending the same stuff, same cookie, but and on every connection you make to the server. So server has to see all these things you're sending back and back and forth, back and forth, back and forth. It just becomes so much CPU consuming, and that's exactly when the HTTP 2 version came in. So before they made like the Google made a SPDY kind of thing. It was made in like 2012. The SPDY was kind of like initiative for the HTTP version 2, but it was not really much HTTP version 2. It has quite a few things. But then the HTTP version 2 came in 2015, and well, now let's talk about HTTP version 2. It's very good stuff, to be honest. HTTP/2 came in 2015. We'll not be talking about the SPDY, which came in 2012, because it's literally HTTP version 2. So, HTTP version 2, what's new in this thing? Well, basically in HTTP version 2, well, normally I said, okay, we can make 6 most active TCP connections are allowed in the normal HTTP 1.1 version. But in HTTP 2, there's nothing like that. There's no limit like that. And you don't even need to make multiple TCP connections because you only make one TCP connection. And how does that work? Well, let me just show you how does all this things work. So let's take this example again. Let's say we're asking for the same stuff. I want these three files from the server. So now, in order to get these three files from the server, we don't have to make three different HTTP requests, or we don't have to create three different TCP connections. Other than that, with the help of the HTTP version 2, we only create one TCP connection, specifying in this one HTTP TCP connection, we ask for these three things. And how do we specifically know which thing stands for what? Well, we don't do like that. I actually do like this thing. Plus, I can just call this a plus like this. It all goes to the server with the same thing. And how do we actually keep these things unique? Like, how do we actually know what is what are we asking? How do we know which request stands for what? How do we want to get which request as what? So for resolving this problem, we set a unique server ID for all of them. Okay. So all of these things that we want in the request are giving a unique server ID. Okay. It's kind of like by default they give them the unique server ID, so we know which file stands for what. So basically, when we get the response from the server back, we will not get the response like normally. Okay, yeah, this is your index HTML, this is your style, this is your script.js, but it will get data back like, okay, this is the server ID, this is the response for this server ID, this is the response for this server ID, and this is the response for this server ID that we asked for. So in HTTP version 2, we don't do stuff like we used to back in HTTP version 1.1, but now in here we make only one TCP connection, and in this one TCP connection, you ask for all of these files, and all of these files have a unique server ID, so they differentiate by themselves. So they have a differentiation. So all of them don't get cramped up together, so you don't get confused. You need to have a uniqueness somewhere so that you will be able to differentiate. You will be able to know which file stands for what. So it's not like you're going to put the script.javascript in place of the index.html, because if there is nothing unique about it, you don't know which file, what came back in the response. So that's the thing. Well, that's one of the things. And the another thing is like it's actually known as the multiplexing. Multiplexing, if I'm spelling it wrong, right? Let me search for Google search. Multiplexing, yeah, multiplexing goes like that. So this thing is also known as multiplexing, that you're creating only one TCP connection and you're asking for different things in only one active TCP connection. And the advantage of this thing is basically you're not creating multiple HTTP requests, you're not making multiple HTTP requests to the server. So server doesn't have that multiple HTTP request load. And bare minimum is the thing that you're sending the header once. Now all of these data, all of this script.js, the style of the CSS, the index.html have one single header. Okay, all of them have one single header. They have the user agent, they have the content length, the host, the post, the method eventually. But the thing is, when you get back the response, you get back the response back in two things. Like we already talked about here in HTTP 1.1, the response looked like something like this. We had the headers, we had the our data body. But in HTTP version 2, we have this header frame and then we have this data frame. So when we get the data back from the server, we get the headers differently, we get headers differently back, we get the data differently back. So they give us okay, let's suppose the unique ID is equal to 1 in this case, unique ID is equal to 2 in this case, and unique ID is equal to 3 in JavaScript case. So once response will be like this, okay, response will be like this. So response will be like, okay, we got the data of server 1, and then after some time we get the data of let's suppose server 2. Okay, let's say we get the actually server 2, we get the headers of server 1, and then we get the maybe data of server 3 because it doesn't have been a sequence. Then maybe we get the data of server 2, then maybe we get the headers of server 2, and then we may get the headers of server 3. Well, usually the headers will be close to the data. Like you get the data, you get the headers, you get the data, you get the headers, like that. Well, why do we get the data and headers separately? Because in HTTP version 2, in HTTP version 1.1, we were only able to put an encoding, we were only able to compress our HTTP body, but not the headers, because we need to send the headers the same way. But in this HTTP version 2, you're also able to compress our headers using the HMAC, or you can also say the what do we say, Hahnemann compression. HMAC full form. HMAC full form stands for HMAC. Okay, no, just the HMAC compression full form. Yeah, it goes like hash-based message authentication. Okay, now actually still. HTTP2 header compression goes with the not HMAC. It's known as HPAC compression full form. HPAC. What is HPAC compression called? It was something like Hahnemann compression. Is it something like Hahnemann compression? Okay, we have it. Oh, it gives me the okay. HPAC compression header. We're gonna call HPAC. Oh, Huffman. Yeah, it's a Huffman compression. I know it encrypts it encodes our headers as in a deflate encoding type. Yeah, it's a Huffman HPAC. So headers gets compressed with HPAC or slash Huffman compression, which is related to deflate compression. As we know, we have the deflate, the gzip, and the BR content encoding supported by default. So yeah, the headers, if the headers are compressed, we can pretty much deal with it. So this is the response of the multiplexing. We get the data with the unique ID of a server, of our whatever data we wanted, and then we get the headers separately. Like we get the headers frame separately, and we get the data frame separately. So yeah, you need to understand these things. So this is the response that we can get back from our request here, that we made only one TCP connection, which was asking for 3 different resources. And you can ask for unlimited resources. There's no minimum or bare minimum limit. Not only that, but this HTTP version 2 lets us help us gives us a new thing, which is also known as a push thing. What is push in HTTP version 2? Well, basically push is like related to something like you're assuming if if a person is going to ask for index.html, then you know what files to send it to him. So before, in the multiplexing, user needs to send us 3 different resources. He's asking for 3 different resources. And all of them, these 3 different resources have the 3 different server IDs. But with the help of this push option, what happens, like basically it depends upon the use case. If the files are being cached, this is a bad thing. If the files are not being cached, it's a good thing. So if user is making a get index.html request and nothing else, because you're only making it because if the user is making a get index.html request, you know that user would also need the style.css file, and he will also need the script.javascript file. You know it because whenever the user comes on a website, index.html is the main page. That means he also needs those 2 files. So you don't want the user to make you don't want the user to ask for these 2 files separately. So what you do, you just give him back response. You give him back something. I'm not gonna put all these data server 1 stuff as that. So I'm just assuming you give the user back the index.html, the style.css, and the script.javascript file. Even though he only asked for index.html, but in response you're giving him back these 3 files, because you know that he will need these 3 files also if he's making a call to this index.html. If he's making a HTTP get request for index.html file. So this is a push function that we have in HTTP version 2. So yeah, this was about the HTTP version 2. How long has the video been already? About an hour. That's fine. Because now we'll be talking about the HTTP version 3 very quickly. I would like to make a brief video about HTTP version 3 soon in the future. So whatever we learned about till now should be pretty much okay. And let's quickly wrap up with the HTTP version 3. And let me say why HTTP version 2 is bad. And yeah, it's bad. Why is bad? Well, I will explain you that thing now. The thing is like, okay, let me show you something. I would say HTTP 1.1 version is also good in this thing. So let me make this case up. So we are saying we are asking for the style.css file from the server, right? And the thing is like, if the style.css file was not found, we're assuming the style.css file was not found or something wrong happened with it. That's fine, because in HTTP version 1.1 we're making a different HTTP request for every single thing. So if this one TCP connection failed, what we will do, we'll just fail it eventually, and these 2 connections will get successful. So we do have the index.html and the script.javascript file, but we don't have the style.css, and that's okay till a point. But this creates an issue in HTTP version 2, because in HTTP version 2 we're making a one active TCP connection, and in that active TCP connection we're asking for 3 different files. And so we are saying in the HTTP version 2, what we do, we make 3 different calls for the HTTP. We make 3 different HTTP request calls, right? Sorry, my bad, my brain is a little bit messed up. We make only one active TCP connection. We make only one HTTP request, which asks for these 3 files. And it doesn't like in the HTTP version 2, it doesn't directly ask for, okay, we are having these 3 URLs. It converts our these things in bytes. Yeah, that's a different level story, but just for a better understanding, it converts our server ID stuff as that. It converts it into bytes. And if something happened with the style.css, if something wrong happened with it, like let's suppose we were not able to process the style of CSS. Maybe something wrong happened. Maybe this style of CSS wasn't the right thing. Something happened. I'm just assuming. Okay. So what will happen? None of other neither the script or JavaScript, neither the index.html request will pass. You will not get the response from you will not get any response from them. It will just reload the whole TCP connection. It will try to get the whole data again because something messed up in the style of CSS. So that's why we're trying to get the whole TCP connection reload again. So if it still occurred, that means we're not even getting the index.html. We're not also getting the script.javascript file, only because something wrong happened with the style.css resource. So this is a very major issue with HTTP version 2. Yeah, it's a very big issue if you consider it as an issue. Something wrong happened with one file and you were not able to get any file because you're making only one TCP connection, which means if something failed in that TCP connection in that response, you will not get nothing. You will not get no response back. Everything will fail. Okay? And that's the thing about using the HTTP version 2, which was resolved in HTTP version 3. And yeah, it was resolved in HTTP version 3. And HTTP version 3 actually does not use TCP connections. And yeah, the thing is, like before making HTTP version 2, they were already thinking like we should get rid of TCP because TCP has these kind of issues. Like you need to follow the handshake stuff. You need to make a request, and when you get a response, you can make another request, then you get another response. So TCP has the limits, but it was very complicated for the people to remove TCP directly because it would have taken decades for a lot of modules, a lot of web servers to actually get to the new thing. So that's why then afterwards they generated the HTTP version 2, and slowly they came to UDP. And yeah, UDP is like a bare minimum transfer protocol possible. So they just said, okay, we're not going to use TCP anymore. We will be using UDP. And I will talk in brief about the TCP and UDP transfer protocols in depth. But as of now, just please understand the basic thing. Okay, how many guys understand literally anything? If you whatever you can. Okay, I need to make a new page, right? Because I cannot type it in here anymore. Or maybe I can. Yeah, I can type properly. Yeah, that's good. So then we came to the HTTP version 3, and HTTP version 3 is probably now supported in, I will assume, in all of the browsers, but it's the latest thing. It came around in 1 second. I think in 2019. Let me just go let Google search. HTTP 3 came release date. Yeah, release date. Yeah, 2019, September 2019. The HTTP version 3 came. So what was good in HTTP version 3 that was bad in HTTP version 2. We already saw this thing. Style of CSS was corrupted, something wrong happened, the whole response got that. And this was fixed in the HTTP version 3. Basically in the HTTP version 3 we are using, instead of making a TCP connection, we make a UDP connection. Okay. And another very important thing to mention. In HTTP version 1.1, it's okay if you don't have a TLS certificate. If you're making a request over HTTP protocols, it's all fine. But in HTTP version 2 and HTTP version 3, it's not allowed. They are not allowing the connection without a TLS certificate, or you can say a TLS connection. So basically, you can only use HTTP version 2 or HTTP version 3 over a HTTPS protocol server. So if you want to test your HTTP version 2 website, you need to upload it to some hosting which provides the HTTPS protocol, means the TLS certificate, the TLS and SSL certificate. So that's another thing. Only works and TLS SSL is must. In HTTP version 2, TLS and SSL is must. The HTTP version 2 uses the TLS version 1.2, and in HTTP version 1.1 you can use it over both the TLS. Either it has the TLS SSL certificate, or if it doesn't, it will run both on both of the things. But the HTTP version 2 is a little bit more specific about the security, so it doesn't allow connections which are not on a TLS or SSL certificates. Like which connection on just HTTP request will not be allowed in this case. So the same goes for the HTTP version 3 basically. I'm not going to talk about how the HTTP version 3 is working, but all I want to mention here is like it does the same thing like the whatever this HTTP version 2 is doing. It connects to only one TCP connection, only one UDP connection, not a TCP connection. In basically TCP connection, we had all the data like this, but in a UDP connection, what we do basically let's suppose we make this 3, which is asking for index.html, we're asking for style.css, and then we're asking for script.javascript, and it adds up all of them in the UDP connection. They use the quick new function. I'm not going to talk about it by I'm not going to talk about it right now because I don't want to make things much more complicated. Okay, TCP, UDP, TA, and connections, TLS, SSL. Whoa, what is this stuff? I will make another videos about this thing. So just keep your horses and let's talk about this thing. I'm not going to talk much in depth in this, but I just wanted to give you some understanding about HTTP version 3. So what it did to solve the issue is basically it puts all of these, the resources that we're asking for, like we do in the. So basically, in HTTP version 2, it puts all of them in one section. Okay, it puts all of them in one connection, like all of them together in one connection. But in HTTP version 3, it does put all of them in one connection, but all of them are specified with a unique server ID. Here also we do have a unique server ID to represent the resource itself. But in here, they all have a different, connection, kind of like connections thing. There's only one. They only make one active UDP connection, but they all have a different server IDs. So in case if something failed, let's suppose if something failed, if like we were unable to get style.css, it will not matter. It will try to get the style.css, even though it will give us a response for the index.html and script.javascript, because it gets all the things separately. Now in the HTTP version 3, it does all the work separately, other than focus, other than saying okay, style.css, something wrong happened with it, restart the whole connection. No, it will not do that. It will only restart the particular thing that failed. No, the whole connection will be restarted. It will keep the connection, and it will give us response back of the index.html and the script.javascript. Okay, let me see. Do we need anything else? And no, we are done. Well, that was a very good 1 hour 20 minutes video, and we learned a lot of things about the HTTP requests, did we? So this was about it, and this is the HTTP version 3 is the latest one that exists till date, till now, till 2023, I would assume, because it's already starting October. Like it's not actually October. It's like going to start in September soon of 2022. So yeah, we have HTTP version 3, but most of the people are not using HTTP version 3. But you may already see the big guys like the Google stuff as that they use the HTTP version 3, and your browser is supporting this already. Okay, just don't say what if the browser will not support it? Then why would Google use it? Isn't that right? And yeah, they use the HTTP version 3. They also use HTTP version 2, but it depends upon the cases. Okay, mostly they will use the HTTP version 3, or sometimes if not needed, HTTP version 3 gets a little bit more complicated. If they want things to be more normal, they will use HTTP version 2, or if they literally don't want to complicate nothing, if they want to go with the default thing, they will use the by default HTTP version 1.1. You don't have to do nothing for that. So that's it about this video. If you're watching this on my YouTube channel, maybe I will upload this video on my YouTube channel. That's fine. Subscribe to my YouTube channel. But if you're watching this on my full stack Udemy course, if you have not joined the course yet, join the course by going in the description. Join the course. But if you're my student, my guy who is watching this from my course itself, well, have a nice day, because I will be sharing you. I will be providing this link for this note that I'm writing, every single thing that I'm writing in here, because I wrote this in one note, and I can share this what do we say? What is this? A notebook, right? I can share the notebook. Other than adding a new page, I can add new page though, right? So yeah, there we go. That's it for this video. I hope you enjoyed this one. It was a very interesting video to talk about. Okay, nice. It was a very interesting video to talk about. You learned a lot of things. I learned a lot of things, to be honest. I was not aware of nothing unless until I don't want to teach you guys. I was not learning nothing. That's about it. I will see you in the next one. Have a nice day.